Hello dear friends, and welcome to this video today in our YouTube channel. In today's video we shall be looking at the correction of the Cameroon Northwest mock mathematics with mechanics, the advanced level. We shall be looking at the question 1 of it. It is mathematics with mechanics, like I said, paper 3. So guys, this was a question that that most of my students, most of the students of our institutions have been recommending for the solution to this problem, because they found it so much more difficult in their own exam. So guys, stay tuned and watch the video from start to finish, because we shall be highlighting errors that students could easily make and ways to which we can remedy all those errors. So guys, please, if you are new to our channel initially, guys, please make sure you hit the subscribe button right now and press the notification icon to get notified each time we upload videos, guys. And please don't forget to like the video. Just press the like button beneath the video, because that goes a long way to motivate us, to give us the courage, to give us the motivation, and it actually tells us that you actually found content like this useful, and we are going to keep doing that for you guys. Thank you very much indeed. Let's get started. So now guys, as we can look at the problem here we have on screen, the question is simply saying that that the position vector of a particle P of mass 6 kilograms at time t second with respect to the origin is given by r equal to e raised to the power 2t in the sense I minus 2 e raised to the power negative t in the sense j meters. Then the Roman one is saying that we should show that initially the particle is not at the origin. Then the Roman 2 is saying that we should show that the particle is never at rest. Then the Roman 3 is saying that we should find at t equals the natural log of 2, a, the kinetic energy of the particle P, b, the magnitude of the force produced by the motion of P. Okay guys, let's start with the first question. So guys, like I said, don't forget to like this video, because that goes a long way to motivate us. Thank you very much for liking, thank you for subscribing. Let's dive straight into it. So guys, to show that the particle is initially not at the origin, guys, we simply have to keep in mind that we must be able to show that the position vector of P when the time t is 0 seconds is not the 0 vector. Good. Keep in mind guys that this is a position vector that has been given in terms of the I and j component, so we must be able to show that initially, that is at time t equal to 0, the position vector when the time is 0 is not the same like the 0 vector. Keep in mind that guys, the 0 vector in this case is simply going to be 0i plus 0j, all that matter. So if we can show that when the time t is 0, the position vector of this position vector when the time t is 0 is not the same like 0i plus 0j meters. So guys, when our t is equal to 0, we are simply going to substitute 0 into the position vector. We are going to have r to be e raised to the power 2t. Our t is 0, we simply have the 0 here, I minus 2 e raised to the power negative t, which is 0 in the sense j, all that matter. So guys, if we simplify this guy, we are simply going to have our r to be equal to, keep in mind that 2 raised to the power 0 is 0 and e raised to the power 0 is 1. 1 times I gives us I. Then likewise, negative 0 is 0, e raised to the power 0 is 1. So we have negative 2 times j, which we have negative 2j, all that matters. So guys, since this our r is not the same like the 0 vector, that's 0i plus 0j, we can clearly conclude that, which is not the same like the 0i 0j, guys. So we can clearly conclude that hence P is initially not at the origin. Good. So guys, don't forget to like the video and subscribe to the channel, because that goes a long way to motivate us. It actually tells us that you found content like this so useful, and we are going to keep doing so for you guys. Thank you very much. So now guys, the next part wants us to show that the particle is never at rest. So guys, this is where most students can get stuck with this particular question, but you watching this video today and getting all the explanation, watching the video from start to finish, will never have anything to bother about. So guys, the question wants us to show that the particle is never at rest. Now, for us to do so guys, all we simply have to do is that we need to show that whatever the value of t, guys, the speed of P is never 0. Keep in mind guys, I said speed I didn't say velocity, okay? I said speed and not velocity. That therefore means that the velocity of a particle can still be 0, of which that particle is not at rest, okay? So if you say velocity here, you are not going to be correct, you are going to be wrong, okay? So that's why I've used the word speed, because if the speed of a particle is 0, that particle must be at rest, okay? The particle must be at rest. So in this case now, I've used the word speed, and that is the correct word you have to use. So if you can be able to show that the speed of the particle at any time t is never 0, means you are done with the equation. Great. So guys, in this case now, and we need to get the speed right. I will know that the speed is simply what? The magnitude of its velocity, right? The speed of p, the particle p, is something like what? The magnitude of its velocity. And now guys, we should know that the velocity of the particle v is given as what? As dr by dt. So we have to differentiate the position vector with respect to time to get the velocity of p. Good. So now guys, if we differentiate, we are simply going to have our dr by dt, which is the same like our v, which is the same as, now differentiating e raised to the power 2t, guys, we are simply going to have the e raised to the power 2t, then we multiply by the derivative of the power, which is what? 2t dt. Differentiating 2t dt, guys, simply gives us 2. That's why we have the 2 in front of it in the sense I. Then likewise, differentiating negative 2 e raised to the power negative t, we are simply going to have our negative 2 e raised to the power negative t, then we multiply by the derivative of negative t, which is simply negative 1. The negative is going to make this negative positive. That's why we have positive 2 e raised to the power negative t in the sense j. All that, guys, in meters per second. Good. So now guys, we can go for now to find the magnitude of v. This is the velocity v, guys. So to get its magnitude, it's simply going to be the square root of the sum of squares of the individual components. So we are going to have 2 e raised to the power 2t, all that squared, plus 2 e raised to the power negative t, all that quantity squared. Good. If we simplify, guys, we are simply going to factor out the 2. We have the square root of e raised to the power 4t plus e raised to the power negative t. But guys, at this point in time, it's so difficult to see that the speed it's so difficult to see that the speed in this case can never be 0. So let's investigate here, guys. Let's investigate what is going to happen. Okay, now we should keep in mind that if we can observe that if we assume, guys, if we assume that the speed of the particle is 0, okay, let's just try to bring forth an assumption. Then if we can prove the assumption correct, we conclude. If we cannot prove it correct, we still conclude based on our analysis. So guys, we should also know that if we assume that the speed of the particle is 0, that means that the speed in this case, we have it what? 2 into square root of 4 e raised to the power 4t plus e raised to the power negative 2t is equal to 0. That therefore implies if we divide all through by 2 and take this and square both sides, guys, we are simply going to have e raised to the power 40, which is equal to e raised to the power 40 plus e raised to the power negative t, which is equal to 0. But guys, we know that no matter the value of t in this case, right, e raised to the power 40 is always positive. Likewise, e raised to the power negative 2t is always positive. So the sum of a positive quantity and another positive quantity, guys, can never give you 0. Okay, I'll take it again, guys. E raised to the power 40 is always positive. It is never negative. Okay, no matter the value of t you take, no matter the real value of t you take, it is never negative, or it is never equal to 0. Okay, so this guy is always greater than 0. It is never less than 0. It is never equal to 0. Likewise, e raised to the power negative 2t as well. So the sum of two quantities that can never give you 0, or that can never be less than 0, can never give you what? 0. So guys, in this case now, we can see that it is quite absurd and impossible. Okay, so in this case now, which has already contradicted the assumption we made. Keep in mind that we assume that the absolute value of v is equal to 0, right? But in this case, we have shown that it is never 0. So it has contradicted the assumption that we made here initially. So we can come back here and say that. We can simply come back here, guys, and say that now, but the square root of 4 e raised to the power t plus e raised to the power negative 2t is always greater than 0 for all t. Keep in mind that 2 in this case is just a constant, it does not change, okay, it does not change. So, and 2 times a quantity that is greater than 0 is still greater than 0, so it doesn't really matter. So in this case now we can draw a conclusion that hence P is never at rest. Great. Thank you guys. Let's move on to the next question. Okay guys, this is exactly what I have here. Now the Roman 2 is saying that we should find at time t equal to the natural log of 2 of the kinetic energy of P, of the particle P, then the B part, the magnitude of the force produced by the motion of P. Okay guys, let's partition our screen. So guys, we have to find the kinetic energy. Guys, keep in mind that let's first of all insert all the quantities that we need. We need the position vector itself. We also need the mass of the particle, that is m equal to that's the P equal to 6 kilograms. And secondly guys, we also need the velocity of the particle P. Good. So now, okay, so guys, you should keep in mind that the kinetic energy is given as what? That's K equal to 1/2 mv squared. Great. We have V already, right? We have the velocity V already, so we simply have to plug in lane 2 and see if we can solve. So now at t equals the natural log of 2, guys, we are simply just going to have, if we plug in the natural log of 2, we are going to have V to be equal to 2 e raised to the power 2, t is what? The natural log of 2 in the sense I, plus 2 e raised to the power negative the natural log of 2 in the sense j, all that meters per second. So guys, if we bring forth 2 to the power, as we know about the log property, if we bring it to the power, and we also know that e raised to the power ln anything is simply that thing, so we simplify guys. Likewise, bringing -1 in front of the 2, which is now going to be 1/2, then 2 times 1/2 simply gives us 1, so we have j this way. So guys, simplifying everything now, it's simply going to give us 8I plus j meters per second. So guys, this is the value of the velocity that we have. Now to get the kinetic energy, we are simply going to have, is simply, like I said here, is going to be 1/2 mv dot v. Guys, keep in mind that most mistakes that students are going to make, this is one mistake that students are going to make, and the accuracy marks, and they might lose marks at some point. The examiner wants you to know that this position vector has been given as what? As in vector form. Likewise, the velocity here is in what? In vector form. So, and vectors are not normally multiplied, okay? Vectors are normally dotted. So we have to dot these vectors and not multiply. Since students know from physics that kinetic energy is given as 1/2 mv squared, once you mention 1/2 mv squared here, the examiner might start looking at your paper now with that's the examiner might take special note while looking at your paper, because the examiner might assume that you simply cram the concept and you've not understood it. So it is going to be mv dot v, since the velocity in this case is in vector form and vectors are not normally being multiplied. Good. So guys, the kinetic energy in this case now, we are going to say our K is going to be 1/2 m. What is our m, guys? Our m is 6 kilograms. Our v is 8I plus j into, we dot it with 8I plus j. So guys, we simplify that correctly, we are going to have the kinetic energy be 195 joules. Good. So guys, this is the value of the kinetic energy that we expect to have. Okay, now guys, the B part is saying that we should find the magnitude of the force produced by the motion of P. So guys, please, if you're not subscribed to the channel at this point in time, just hurriedly hit the subscribe button and turn on the bell icon so that you get notified, because we upload videos every day in this platform. Guys, don't forget to like the video, give it a like, because that does motivate us to produce more and more content for you. Thank you very much, guys. So now the force, guys, keep in mind that, guys, the force is given as what? M dv by dt. It is normally given as ma, where m is the mass, e is the acceleration, but in this case now the position vector is what? Is a variable, okay? It is not constant. Likewise, the velocity in this case will not be constant, because it does depends on the value of t, okay? And e raised to the power x, where this x can be 2x, that is e raised to the power anything as far as the power is a variable, once you differentiate, integrate, or whatever, it still remains constant. Okay, it never dies, it never changes. So and since the velocity in this case is not a constant, we are going to have the acceleration to be dv by dt. Guys, keep in mind that that this is a variable acceleration problem. Okay, the acceleration in this case is not a constant. So the equations of motion that we know, or the Newton's normal law, where a is a constant, will no longer function. We are going to replace the a in this case by dv by dt, since the dv by dt in this case depends on t. Good. So now, since we have the velocity to be v equal to this, all we now have to do now is simply to differentiate the velocity with respect to time to get dv by dt, or the acceleration. Good. So guys, if we differentiate the velocity, guys, we are simply going to have our dv by dt to be the same like differentiating this, guys, simply gives us 2 times 2 gives us 4 e raised to the power 2t. In the sense I, then the negative comes, we have minus 2 e raised to the power negative t, in the sense j meters per second squared. Good. So now, guys, when the time t is equal to ln 2, we are simply going to have when t is equal to ln 2, we are going to have dv by dt to be equal to plugging ln 2 into everywhere, guys, in a similar manner like how we simplified here, guys. If we simplify so well, we going to have our dv by dt to be the same like 16i minus j. Good. 16i minus j. So that's what we have. But guys, they want us to get the force. We also know that F is m dv by dt. Keep in mind that this is our dv by dt, which is the acceleration. So to get a force now, F, we are simply going to take F is the same like the mass is 6 into the velocity. Good. So this is the value of the force in which we have. This is it. This is the force in which we have. But the equation wanted the magnitude of the force produced, the magnitude. So we are simply going to take the square sum of squares, guys. This is simply going to give us our magnitude of F to be the same like, we keep the 6 outside, since the magnitude of 6 is still 6 into the square root of oops, guys, there's some error here. Okay, there is some slight error here. This is what I'm supposed to be 16, not 96. Okay, this is what I'm supposed to be 16 and not 96. So I'll see if I can change that. Oops. Just wait, guys, let me see if I can change it. I'm sorry for that, guys. I'm actually sorry. So guys, I'll just see if I can correct that. That is supposed to be 16. Okay, that has to be 16. This is supposed to be 16, guys, not 9. This is supposed to be 16. Okay, it's supposed to be 16, and here it's supposed to be negative. This is supposed to be negative 1, guys. I'm sorry for this mistake, guys. I'm so sorry. This is supposed to be negative 1. Good. So guys, if we simplify that so well, we expect to have an answer of the square root of, we have 16 squared plus 1 squared. That's going to give us 6 times the square root of 257 Newton. So guys, this is the correct answer to the problem. Okay, this is the correct answer to this our question. This is it. So thank you very much, guys, for watching, and please don't forget to subscribe to the channel at this point in time, guys. Hit the subscribe button, the video, because that goes a long way to motivate us to keep producing more and more content for you, guys. Question 2, question 3, question 4, and so on. All the other questions are coming in as soon as this video ends. So guys, subscribe to the channel so that you have access to watch it, and like the video very much, and have a great day.